This video is on solutions. First, you need to know what a solution actually is. So a solution is anything that has two or more substances involved. So you always have some sort of solute and solvent. Solute is the substance that's being dissolved. Solvent is the substance that the solute is dissolved in. So for instance, if this were a cup of salt water, the salt would be the solute because that's what's being dissolved, and the water would be the solvent. Here are some more examples. Water and air. The solvent is the air, the solute is the H2O, because water vapor is mixed in with the air. Soda, this is an example of a solution does not necessarily have to be in liquid form. So for example here, the solvent is the syrup and the solute is the carbon dioxide that's been dissolved inside of it. Sugar water, which is the same thing as salt water, your solvent would be H2O, your solute would be sugar. Stainless steel is an example of a solid that is a solution. Typically your solvent is going to be whatever you have the most of, and the solute is whatever you have least of. Now, we're going to talk about a couple things where you can change the rate of something. So the first thing we're going to talk about is factors affecting the dissolving rate. So if you can think about making sweet tea, there's three things that you're going to do to make the sweet tea faster. So the first thing you're going to do is boil some water, and you're going to get the temperature hotter. The reason you do this is because as temperature goes up, dissolving speed goes up. So they are directly related. The higher the temperature, the faster things dissolve. Then, once you get the sugar in there and everything, you stir it, because agitating makes the dissolving occur faster. You could actually shake it, or any kind of disturbing of the particles causes them to dissolve faster. Lastly, surface area. We've talked about surface area before when talking about reaction rates. So it does the same thing here. The more crushed up particles are, the faster they dissolve. So instead of using sugar cubes, typically you use granular sugar to make sweet tea. Next, we're going to talk about solubility of solutions. Now, this is how much can actually dissolve in a certain amount of water. So the first thing is you have three different types of solubilities. Saturated solution is when you have pretty much the perfect amount, meaning you're not going to dissolve anymore, and you could still, you can't dissolve anymore because then it'll become one of the other ones. Or if you take some away, you'll become unsaturated. So unsaturated means not saturated. This means it can hold more. Okay, so you could add more if you want it, it will still dissolve. Supersaturated means that it's unstable and solute can come out. So this is like having a glass of sweet tea cold and you try to add more sugar to it and all the sugar goes to the bottom. Even after stirring, it's still there. This is a supersaturated solution. You have solute at the bottom. Now, the slide previous was talking about the rates that affect the dissolving rate. Now we're going to talk about the factors that affect solubility. So how can we see if something's going to dissolve or not? So the main thing you've got to remember is this phrase right here. Like dissolves like. Right there. What this means is that your nonpolar molecules can only dissolve nonpolar. So if you have a nonpolar substance, it will only be able to dissolve another nonpolar substance. A polar substance can only dissolve a polar substance, and some, depending, ionic. So nonpolar can only dissolve nonpolar, polar can only dissolve polar, and your ionics. So most people know that oil and water don't mix. The reason for that, though, is because oil is nonpolar and water is polar, so therefore they will not dissolve, so therefore they won't mix together. Now, some examples of where they do dissolve, so they are soluble, is sugar water. So sugar is polar and water is polar, so therefore they will mix together and dissolve. Water and table salt, which is NaCl, table salt does dissolve in water. That's because water is polar and NaCl is ionic. Nonpolar mixture, oil and methane, which is CH4, they will mix together and dissolve, so therefore they're soluble.